Welcome again in virtual classes of physics from Study Point Inter College, Hyderabad, Singapore. In previous video, we have solved the problems of the physics paper set number 1, year 2016, objective type questions and very short questions of 1 mark we have solved. In this video, we will solve short questions of 2 marks. Section C. First question is given. Question number 3, part first. Write down the Gauss theorem of electrostatics. And you know that closed integration, closed surface integration, d phi e is equal to closed surface integration vector e dot vector ds, which is equal to sigma q upon epsilon naught or k epsilon naught, where d phi is electric flux penetrated and a surface enclosed by a system of charges sigma q, vector E electric field intensity, and ds is the area vector. K is dielectric constant of the medium and epsilon naught is the square. If the charge is placed in air or vacuum, then K equal to 1. Then according to Gauss theorem, electric field from the surface d phi will be sigma q upon epsilon naught. If there is only one charge, then this theorem reduced as delta surface integration d phi equals q upon epsilon naught. So we can say that total electric flux penetrating any closed surface area which encloses an isolated charge small q is 1 upon epsilon naught times of the amount of charge. Next, a question is also given that find out intensity of electric field at a point outside a uniformly charged thin spherical shell with its help. It is reduced from the syllabus. Question number 3rd, part B. What do you understand by internal resistance of a cell? You know that a cell has two terminals. One is positive terminal and the other is negative terminal. By our convention, we say that electric current flows from higher potential to lower potential means from positive terminal to lower negative terminal, and electrons flows from negative terminal of the battery or cell to positive terminal, like this. So chemical substance which is filled in this cell offers and oppose in the path of the flow of electrons. This characteristic of opposing the path of the flow of electron by the material of the cell is called its internal resistance, and this oppose produces some amount of energy in the form of heat and light. A numerical is given along with this question. The potential difference of a cell becomes 1.8 volt. V1 equal to 1.8 volt. When 0.5 ampere current is drawn, I1 equal to 0.5 ampere. When 1 ampere current is drawn, I2 equal to 1 ampere. It becomes 1.6 volt. V2 becomes 1.6 volt. Find the internal resistance of the cell and its EMF. We have to find internal resistance and EMF. So we use this formula. Current drawn from the cell I equal to capital E upon capital R plus small r. It can be written as capital R plus small r equal to E upon I. By Ohm's law, V upon I plus small r equal to E upon I. This implies that small r equal to E minus V upon I. We will use this formula for different potential and different currents. So we can write E minus V1 1.8 upon I1 0.5 equals E minus V2 1.6 upon I2 1, or E minus 1.8 can be written as 1 by 2 equal to E minus 1.6, means 2E minus 3.6 equal to E minus 1.6. 2E minus E equal to 3.6 minus 1.6 means E will be 2.0 volts. Now small r equal to E minus 1.8 upon 0.5 and it also equals E minus 1.6 upon 1. So we can say that small r equal to E, in place of E we can write 2.0 minus 1.6 upon 1 means r equal to, it is obvious that 0.4 ohm. This is the answer. Next question. Explain photoelectric emission on the basis of quantum model of light and derive Einstein's photoelectric emission. First part, photoelectric emission on the basis of quantum model of light. You know that according to quantum model of light, light travels in the form of photon and each photon having energy E is equal to h nu, where h is Planck constant. So we can say that E is directly proportional to nu, and nu is the frequency of light. Frequency is greater than an energy associated will also be greater. And any metal surface, you know that number of electrons are revolve around nucleus like this. And several electrons are free to move inside metal surface like this. These electrons are free to move inside metal surface. If any photon gives its energy E is equal to h nu to any one of the electron, then this electron can obtain kinetic energy. A minimum energy is required to emit this electron from this surface. This minimum energy is known as the work function of the metal. It is denoted by W. W is equal to h nu naught. It is minimum energy, and nu naught is the minimum wavelength which is required to emit one electron from the metal surface. So if the energy provided is less than this minimum energy, means E less than W, then no electron will emit from the metal surface. If the energy provided is greater than W, then electron will emit, and remaining energy means difference of energies E minus W will be converted in the form of kinetic energy, which will make to move the free electron from the metal surface, means E minus W equal to half V maximum square. We can write H nu minus H nu naught equal to half m V maximum square, or H in bracket nu minus nu naught equal to half m V maximum square. In other form, we can write H nu is equal to C upon lambda. So we can write Hc in bracket 1 upon lambda minus 1 upon lambda naught of equals half m V maximum square. Well, nu naught is known as threshold frequency of the metal, and if accelerating potential is V, then the kinetic energy half m by V maximum square is also can be written as EV. If the potential is V naught, then energy will be EV naught. So this expression can be expressed in the form lambda naught minus lambda upon lambda naught equal to half mv maximum square equal to EV naught. This is the required expression, and according to question, we have to solve that. Derive Einstein's photoelectric emission. This is the derivation which is required. Next question, construct logic symbol, Boolean expression and truth table for AND gate. But this question is out of syllabus in this year, and in choice there is another question, potential difference between 2 points is 60 volt, sorry. In this question, potential difference is given delta V equal to 60 volt. 60 volt is given. How much work done in taking a charge of 3 into 10 to the power minus 5 coulomb? Charge Q equal to 3 into 10 to the power minus 5 coulomb. 1 point to another, means we know that delta V equal to W upon Q. This implies that W is equal to Q multiplied by delta V. So it will be 3 into 10 to the power minus 5 multiplied by 60, means 180 multiplied by 10 to the power minus 5 joule, or 1.8 into 10 to the power minus 3 joule. This will be the answer. Next section, section D. In our next video, we will solve section D. Till then, keep watching. Thank you. Stay safe, stay home, and stay healthy.